Hey, who closed the system? It's sublimin in here. That's right, boys and girls. We're doing a triple point lab on dry ice. Boys and girls, it is now time for our analysis and conclusion. With the conclusion to our experiment, it brings us to our first question. What conditions were necessary to liquefy dry ice? Well, two specific conditions were necessary. The first one being the correct temperature, and the second one being the correct pressure. Our second question is, what's a triple point? A triple point is the temperature or pressure at which the three phases, gas, liquid, and solid, of the substance coexist in a thermodynamic equilibrium. We can see a triple point on a graph right here. Our third question is, what is carbon dioxide's triple point? Carbon dioxide's triple point can best be seen on a phase diagram. We see that at its triple point, it meets at a temperature of -56 degrees Celsius and an atmospheric pressure of 5.11. Our fourth question is, why can't CO2 melt under normal classroom conditions? And why can it sublime? Well, the liquid form of dry ice is simply not stable at ordinary pressures and temperatures. Literally, the only time it would be able to melt is if it was at a pressure greater than 5.11 atm. But it can sublime if in a closed system, much like in our experiment. If it is in a closed system, the pressure will increase to a point where the liquid form of carbon dioxide can be seen. Now let's compare a phase diagram for CO2 to a phase diagram of water. We can see that they both have a triple point, a critical point, and a sublimation curve. However, they do have two different things. Their pressure values are different, and their temperature values are different. As we can see, water has a triple point of 0.098 degrees Celsius, a freezing point of 0 degrees, or 1 atmosphere of pressure, a normal boiling point of 100 degrees Celsius, and a critical point of 374 degrees Celsius. Whereas carbon dioxide has a triple point of -56.4 degrees Celsius, or 5.11 atmospheric pressures, a normal sublimation temperature of -78.5 degrees Celsius, also equaling 1 atmospheric pressure, and a critical point of approximately 31.1 degrees Celsius. So there's a lot different between them. Thanks for watching, kids! Throughout this experiment, you were able to explore the changes of state of an unusual solid, being me, dry ice. Well, have fun, and don't get any frostbite.